Alright, so let's wind up on our class for today. Let's complete what we have for today. So we've talked about the chromosome. So it's a thread-like structure made up of nucleic acid and proteins found in the nucleus. In somatic cells, there are 46. In sex cells, there are 23. So there are two types. We have the autosomes and we have the sex chromosomes. Autosomes, they are usually those ones that control every characteristics of living organisms like humans. They control size of your ears, shape of your nose, your fingerprints, and the rest, all characteristics except the gender. Except your gender. They control all other characteristics except the gender. So these chromosomes in the nucleus, you know the somatic cells, all the cells in every part of your body, they have these autosomes, and so they control all characteristics except the gender. So these sex chromosomes are usually, they are still found in all the cells, you get, but they determine, so all the cells have a particular sex chromosome depending on who you are, whether you're a female or a male. You get, if you're a male, you have XY. If you're a female, you have XX. And then the autosomes are usually 44 in number. So they have 2 sex chromosomes and 44 autosomes, alright? So what these sex chromosomes do is they determine the sex. They determine the sex. They're either X or Y, alright? So somatic cells usually have 46, and in the 46 we have 44 autosomes and 2 sex cells. So it's these sex cells that differentiate now. These ones, they are different. In every individual, they differ, you get, because chromosomes, they differ in different, depending on their structure. They can differ in the overall length. They can differ in the length of their arms, you get, and other characteristics, alright? But these sex chromosomes is what differentiates a male from a female. In males, they usually have XY, while in females, they usually have XX, you get. So if you're a male listening to me right now, you should have 44 autosomes and XY chromosomes in all your cells, all your somatic cells, you get. But if you're a female listening to me right now, you're going to have 44 autosomes and XX, 2XX X chromosomes in all your somatic cells, alright? But in your sex cells, that's those cells that has gone into first meiotic division. You know there are some cells in your gonads that have not gone into first meiotic division. Like you have the spermatogonia and and the oogonia. So spermatogonia, which is found in males, and the oogonia, which is found in females. Those ones have not gone into first meiotic division, alright? So those ones, they are still somatic in nature, alright? But those ones that have gone into first meiotic division, they are having 23 chromosomes, which is 22 autosomes and 1 sex chromosome. So these sex cells now, you know, is either sperm cells or the ova, you get. So if it's a sperm cell, it's going to have X chromosome and 22 autosomes. If it's a ovum, it's going to have, okay, this X chromosomes is usually found either in male, which is the sperm cell, or in the ovum, while the Y sex chromosome is found only in the sperm cells, alright? So that's why the males are the determinant of sex of a newborn, alright? Because they can either have X or they have Y in their nucleus, alright? So when fertilization occurs, union of the male and female sex cells, what happens? A newborn is born. It's either a male or a female. If it's a female, that female is getting 22 autosomes from the father, 22 autosomes from the mother, which is making up 44 autosomes, and then is getting X chromosome from the father and X from the mother. That's for the female. Then for the male, is getting, if it's a male, you're a male listening to me, you have in all your cells, somatic cells, 22 autosomes coming from your father, 22 autosomes coming from your mother, and then X chromosome coming from your mother. In this case, it's coming from your mother, and then the Y is coming from your father. You know the Y cannot come from your mother, alright? From the ovum. The ovum usually has X, alright? So that's it for the chromosomes. So this is the typical structure of a chromosome. This is the telomen, this is the short arm, and this is the long arm. You can see how it is. This is the telomen also, and you can see this is comprising of, this is a chromatid and this is another chromatid, and it's joined at the center. It's not usually the center because this is not the center, because this is a short arm, this is a long arm. So it's joined at this point by this centromer. This is the centromer joining the two chromatids. Alright, so there are some important things I want you to take note of. That chromosomes, these chromosomes, they usually are not visible under light microscope. That's when cell division is not occurring in normal state, resting state. You can't see them under a light microscope, alright? But they become visible under light microscope during cell division. So it's only during cell division that you see the structure. It becomes visible, thread-like, long, and you can thicken as it continues divide. As the division process occurs, it becomes thickened, divide, become bipolar, and so on. It becomes divides into 2, into 4, and the rest. So I'm going to talk about that in our next class, alright? And then another thing I want you to take note of is that chromosomes, they differ in their total length. So every chromosome have their specific length, alright? And they also differ in the relative length of the arms. So this short arm and this long arm. The chromosomes, they are different too. In your nucleus, all the chromosomes in the nucleus of a somatic cell, they all differ. They all differ. And that is, there's a term called karyotyping. Yes, karyotyping. So when you produce a karyotype, you will notice that they differ. And what they differ in is, they differ based on their total length, differ based on the relative length of the arms, which is the short arm and the long arm, other characteristics that differentiate them. Alright. So another thing I want to take note of is that this chromosome, as you can see, within it, you have DNA strands. You have DNA strands. Alright. And in this DNA, there is genetic codes. We have genetic codes. If you study your biochemistry of nucleic acid, you will know those genetic codes. So it has genetic codes. This is a gene, and this gene is responsible for the characteristics that every individual possesses. Alright. So this DNA goes into it goes into a process called transcription. First of all, duplication, transcription, then translation. That is genetic interpretation, or whatever you call it. So it's going to go into this process, and then it will form what? Protein. That's protein synthesis. It's going to be form proteins, alright? When it forms these proteins could be enzymes, these proteins could be hormones, these proteins could be structural proteins. Are you get? And these proteins are what determines the characteristics of an individual, because they control a particular function in an organism. Alright, they control a particular function in the cells that are present in that organism. Alright, so your body is made majorly of proteins, more of proteins. So these genes now, this DNA now, is responsible for the characteristics that you possess, alright, as an individual. So this DNA is found in the chromosomes. So that's it for the chromosomes. So what are you going to focus on for this class? So what I have you focus on this class is this. Focus on this. This is the basics of the class. How fertilized oocyte develops into a newborn, and it takes 9 months. First 2 months is the critical months, and the developing baby at that month is called the embryo, and then from the 3rd month to the 9th month is the developing baby at that month, at that period, is the fetus. So let this be in your mind, alright? Let this picture be in your mind. Alright, so another thing I want to take note of is this, the gonad. This is what produces the sex cell, testis in males, and this is the fallopian tube. This is the ovary, which produces the sex cell in females, and this is the fallopian tube. This is where fertilization occurs. So the sperm cell will travel through this part, vagina, travel through the cervix, goes into the uterus, and then from the uterus it passes through this entry into the fallopian tube, the ampulla region. The fallopian tube, GF fertilization occurs. So take note of this diagram also. The diagrams are very important. That's why they were inputted. So take note of the diagrams. And this is the structure of the sperm. This is the structure of the oocyte, matured oocyte. So you can see how it occurs, fertilization occurs. We're going to talk about fertilization in details because there are procedures. You get, there's a process. We're going to talk about it. It's going to penetrate through the zona pellucida. It's pass through the corona vagina first. There's something that occurs, pass through the zona pellucida, then pass through the cell membrane, which is plasma membrane, and then the nucleus of the sperm unites with that of the matured oocyte, and fertilization occurs. Alright, so we're going to discuss them in full details. So this is just a basic class, introductory class. Alright, so that's what I want to focus on. So I don't know if you know about this mitosis. I believe you know the processes. You know the processes: interphase, prophase, this metaphase, anaphase, and telophase. So in the next class, we are going to talk about the cell division, we're going to talk about mitosis, we're going to talk about meiosis. So I want you guys to give answers to these questions because these are focus questions for this class. So after this class, you should already know what embryology is. So tell me in the comment section below, what's embryology? Just briefly. Then tell me what differentiates embryo from a fetus. How many chromosomes do you cells in your testes for the males? How many does it contain? Then what do you understand by spermatogenesis and oogenesis? And how many chromosomes does a newborn contain? Alright, so it's good to have you guys in this section, in this class. So we are going to be talking about cell division in the next class. So take care.